Merci Elena, merci Stan pour l'invitation. And this is the end of my French. I'll switch to English. It's really a pleasure to be here. And I want to start by reminding us how serious is the current situation we live in. Numbers by UNICEF 2015, 21 children under 5 years of age die in the world for causes related to poverty every minute. These are pictures from poor neighborhoods around Rio de Janeiro, Salvador de Bahia, and also Buenos Aires. And this is, I know, also representative of many countries in Africa, of course, and Southeast Asia, and even in the developed world, in some areas of the developed world. In those environments, children have very limited access to basic resources that involve nutrition and sleep. So the food is restricted, people have to share the limited amount of food that is available, and they also need to share their beds. They need to sleep together, and their sleep gets interrupted, the sleep is fragmented. So this is such a basic thing for people in the middle class, but people that in low SES communities don't even have the ability to sleep properly. What is interesting is that everybody agrees in the East, in the West, the atheists, the religious ones, the right, the left, everybody agrees that the school is the place that can fix that can give access to higher levels in society, that we can level the game through the schools. But are schools equipped to do this? So we know that this is not the case. The schools are really not equipped, the teachers are not endowed with powers to really change the situation. And in fact, the school system tends to replicate the inequality rather than really solve it. I will make the points today, what I try to make, the take-home message in a way, is that in poverty, biology comes first. That we have to talk about, the pedagogy, the psychology of learning, but when people are really poor, if they haven't eaten, and if they haven't slept, there's not much you can do. And this is the case for most children, but not only in poverty, because nowadays we have a crisis of everybody being on the internet all the time. So even in the middle class and even the upper classes, the children don't go to sleep anymore as they used to go, as early as 8 or 9 p.m. And it's very common that the children arrive at school completely sleep deprived. So I will make the points that nutrition and sleep, and at the end I will also mention briefly exercise, are low-hanging fruits. Those are things which we can harness, and they're very low cost, but they can have an impact, a sizable impact on education, especially in low SES communities. I will be very brief on nutrition, and I'll extend myself on sleep because this is my realm of research. I just want to remind everybody that 70% of the glucose used up by the body is used up by the brain. The brain does not have glycogen, it does not have sources of energy that can be available readily, so it does need a lot of glucose. Perhaps the person that has been studying this the longest and with most results is Paul Gold. He's been administering all kinds of substances to people and also to rodents to see what can boost learning. And he found that glucose is even better than, say, for example, norepinephrine, which is very good for learning. This is experiments done in the 90s with college students that received glucose versus saccharin as a placebo that has no caloric value. And he got up to 35% of improvement in remembering a passage of prose, for example, when people receive glucose. So the way we think about nutrition in schools should change, because the way it's usually done is that it's decoupled from the rest of the activities. Yes, children eat meals in schools, but these meals are usually not designed to improve learning. And there's plenty of opportunity for research here. And this hasn't been really explored in the classroom. So I would say this is one particular opportunity for people willing to do a master's or a PhD, and it's also an opportunity to engage teachers in research. This is one thing, I'm going to talk more about this later, is that if we want to do experiments in classrooms, we need to do it with the teachers, including having them in the team, including them having them as co-authors in the papers. One of the papers I'm going to show today has the teacher as a co-author. And sleep is evidently one of those low-hanging fruits because everybody has to sleep, and pretty much everybody is sleep deprived. I'm very much sleep deprived because I just arrived from Japan, but I'm sure that more than half of the people here also could get a little, could benefit from a nap. When I started my research on this topic, I was coming from the lab. Most of my work before establishing my own lab was done in the rat hippocampus and studying sleep and memory in rats. When I got back to Brazil, I decided to apply some of this knowledge in the classroom, because we have evidence for pretty much, almost like a century of evidence that post-training sleep is very effective to help the consolidation of memories. So why is it that we don't apply this in the classroom? The first experiment that I conducted was very simple experiment conceptually. It was basically the notion, try to assess the notion that a nap after learning new content could either improve the amount of things learned or the duration of the learning. For this was a master's done by Natalia Lemos. Oops, no, here. This was done with 6th grade students. We did a pretest on contents that they were not supposed to know at this age, that involved the brain and involved the nervous system and memory. And then we gave them surprise post-tests at 1, 2, and 5 days. So the idea was that they wouldn't go home and study anything because they didn't know there was going to be a second test. There was a lecture on vision and memory for 15 minutes, which was given by the student, by the master student. And then the students were the children were randomized in 2 groups. Half went to sleep on mats with masks, and half went to other classes or went to a break, like having, playing, basically. We wanted to keep it very simple so that it's actually applicable to the school environment in a developing country like Brazil. So nothing fancy, no good beds, nothing fancy, but the basics, mats and masks. And then we came 1 or 2 or 5 days later to see what had happened. And what we found is that if you go there on day 1, both the group that had the nap and the group that remained in waking show a 10 to 12% improvement over the pretest scores. So just having the nap didn't make them learn more. The contents that they were able to, the new contents that they were able to learn didn't really increase in amount. But 2 days later, we started to see a decrease. And 5 days later, we saw that the group that had waking went back to 0. So they learned, probably, because we didn't test the same kids, but then they unlearned. While those that had the nap seemed to have these memories protected. So this first experiment suggested that the nap after the learning is not really increasing the amount of learning, but it's increasing the persistence of learning. This experiment was published in 2014, and believe it or not, it was the first such experiment in classroom. There was another experiment around the same time by Rebecca Spencer, and to this day is still a handful of studies. So this is a huge opportunity for research. Those are relatively simple experiments, but very relevant. This experiment was criticized, though, and it was criticized for mainly 2 reasons. One is that the person offering the lecture was not the teacher. It was somebody from the university, somebody they never saw before. This in itself can change things. There's evidence that just by increasing novelty, you affect the learning a lot. So having children moving from one room to the next has an impact on learning. So this was a criticism, a valid criticism. Another valid criticism is that the contents were not curricular. They were not what they were supposed to learn, but it was something that we made up, that we took off the hat. A third criticism that is valid is that we studied different children. The different groups were comprised of different children, which was not balanced from the beginning. It was just my first experiment on this. So we decided to address these criticisms on the second experiment. This was done by Tiago Cabral, who was a master's student. Mark McDaniel was involved in the design. And here rather than studying hundreds of children, but assessing them only once, we studied the same 24 children for 6 weeks in a design in which we shuffled them every week so that every child could participate in every group. And it worked like this. We got the contents of the week. It was 3 weeks of science and then 3 weeks of history, exactly the same contents that they would get normally, and it was given by the teacher that they already had, who was involved in the study. And we divided the contents in three parts, A, B, and C. On Monday, all the students had content A together, and then half of them went to sleep, and half of them continued in class and received content B. And then they had a break. On Tuesday, all of them had content C together. Those that had slept the day before received content B, so that they all received all 3 parts. While those that didn't sleep the day before then got their sleep. So you see here we formed 3 groups. One group that has content followed by sleep, one group that has content followed by more content, so this is specific interference, and one group that had content followed by the break, so non-specific interference. And we just shuffle them every week. What we found was the following. For children that had short naps of shorter than 30 minutes, we saw no benefit. We saw that the groups were, in average, the same. This is individual data. You can see that different children do different things. Some improve, some decrease, but in average, nothing happens. But when we look for the children that, when they had long naps, more than 30 minutes, there was a significant effect for the nap group. So the nap group showed about 10% more, better performance than the other groups. And you can see here for individual data that most children tend to either improve or remain the same, but the sleep is not doing anything bad to them. So this experiment was received with more interest by the community because it was better controlled and it was much more naturalistic. It really was very similar to a natural situation in the school. We decided then to move on to another problem in the same direction that has to do with illiteracy, right? There's estimated 750 million illiterate people in the world. And one of the things that you see when children are learning to read and write is mirror writing, right? So for the Latin alphabet, the confusion between the B and the D or the P and the Q, which is very common. You see this happening to pretty much every child, and it takes about 1 to 2 years to be solved. In some bad cases, it takes more, 3 or 4 years. And we recently started to study an aging population of semi-illiterate people, and we find that people aged 60 or even 70 can still show mirror writing, and the mirror writing then gets to be mirror writing of the whole word. So if you can't decode the letter, you can't decode the word, and then the whole thing becomes impossible. We decided to tackle this question, following up on the path opened by Stan and his group in this celebrated paper that showed that the visual word form area, an area in the brain that is necessary for the decoding of letters, which is an area that is actually used for face recognition, there is a trade-off between learning to read and write and recognizing faces. And this provides a rationale for why mirror writing occurs. Because if the area that is recycled for reading is an area that evolved, not for reading, of course, but for face recognition, then the properties of face recognition will apply in the early stages of reading. So this is the notion proposed in this paper in 2000, that if all you need is to recognize a face and react to it, it doesn't matter whether you're seeing it from the left or from the right profile, right? So the reward is on very fast processing, and the eventual asymmetries of a face are completely irrelevant. But for reading, it's exactly the opposite. And this is a rationale for why it takes long for children to overcome this problem. So if this is the case, it means that the visual system is the culprit. It means that we need to bypass the visual system in order to get this to work, right? So this was work done in collaboration with Felipe Pegado. Felipe was a postdoc with Stan, and he's now in Marseille. And this is it was the master's work and now the PhD work of Ana Raquel Torres. So we decided to see whether we could make the children, 5 minutes, perfect. Whether we can make the children learn fast with multisensory training, which bypassed the visual system. So the children were blindfolded, and they received a variety of experiences. So for example, write the letters while being blindfolded, or having a peer write the letter on your hand as you're blindfolded, and then vice versa, or then using the hands left and right to indicate to which side is the, as we say, the belly of the letter. Right? And the whole idea was to use the auditory, the somatosensory, and proprioception to bypass the visual system and see if that will make the learning be more efficacious. We studied the following groups. One group that was trained, as I described. One group that was trained and then received sleep. One group that received neutral training, which was exactly the same as the training, except that the letters were symmetric. So the only difference was the content that was being learned, and one control group that didn't receive any treatment. We also studied the group that just slept, but nothing happened there. I'm not even including it here. And then this lasted 3 weeks, half an hour per day, followed by long naps. And then after 30 days, they were tested, and then again 120 days. So what we found was the following. We did 2 replicas, and the 3rd replica was pre-registered, and we are right now quantifying it. So this is one experiment, and this is a replica of the experiment. In the pre-test, you see that the children all performed the same. Of course, here we did balance the groups. So you see that they're all the same, around, the median is around 0.3. In the post-test at 30 days, both the group that had the training and the training plus sleep, they improve up to 100%. So the training works. With 3 weeks of training, they get almost 100% of performance, while no effect for the control, no effect for the neutral training. This is very important. And you have the same thing for the other replica. However, at 120 days, the group that didn't sleep starts to go down, starts to unlearn. So all this effort will be washed away if there is no sleep to crystallize, to consolidate the memory. You have very similar effects when you look at the response times, right? So the response times are much lower for the trained than for the non-trained, even better for the ones that got sleep. But then the ones that don't get sleep at 120 days, they start to roll back. And interestingly enough, the reading speed is really, really good for those that got sleep after training, but not for anybody else. So the conclusions of this is that the multisensory training for 3 weeks eliminates mirroring variance for letters, but the post-training naps increase the memory persistence. If there are no naps afterwards, this is probably a waste of time, because everything is going to be washed away. We now have some data that I didn't bring here because it's not with a large N, but after 1 year, they're still 100%. 1 minute. Okay, so the point here is that sleep, nutrition, and exercise are low-hanging fruits. We should pick them first, especially in low SES communities. And those are opportunities for research, right? So to really study in a controlled manner the difference between having a break, rest, what is the difference between slow wave sleep or rapid eye movement sleep, pre-training, post-training sleep. In the case of nutrition, hydration, caloric intake, meal composition, micronutrients, serving sizes, all those things are opportunities for researchers. We should study those things because this is relatively easy and probably with a lot of impact. And the final point, if Elena allows me, is to make an analogy with organic agriculture. If you want to increase the output of a plot of land, you can do it in basically 2 ways. The traditional way is you increase the input. With more workers, with more fertilizers, with more machines, you get bigger output. But you can also do it by, rather than increasing the input, using the information in a smart way, moving things around. Get the pigs, the pigs here, take the chicken, go there, and moving things around in the plot of land, you can get more out of it. Maybe we can do the same with education. Maybe we can have shorter classes, because classes that last 1 hour or 50 minutes, or 55 minutes, as I learned in Entre les Murs, they don't really work because everybody gets bored. There's primacy and recency and everything in the middle, we don't care, right? And then use this time to do some testing at the computers and then get the right nutrition, the right sleep, and the right exercise, which I didn't have time to touch. So that maybe we can get out of this situation that we are currently, that we are so wealthy and still so badly educated. And then we can start to level the field, right? So that we can escape this kind of future and start doing some ecological cultivation of the mind and get to this level here. Thank you very much.
You press the number 1. Donc, des questions. Levez bien la main, surtout si vous êtes en haut, parce qu'il paraît qu'on ne vous voyait pas assez avant. Ghislaine. Ah. On n'entend pas.
So in our experiments, we always did the sleep either right after learning or right after lunch, because we found that it's hard to get the children to sleep before lunch for physiological reasons, but right after lunch is great. There's a study that I reviewed and that should be coming out soon, that coming from Singapore, showing that if you mimic a regular school week in school in which the children sleep like 9 hours during the weekend and then 6.5 hours during the week, there's no problem with the learning in the morning, but there's a lot of problem with the learning in the afternoon. And this can be completely resolved with one long nap.
Actually, I have 2 questions regarding what you're just talking about. One was about the timing. The other thing was actually, there's a tendency to going, a lot of people are going vegetarians and vegan. Have you had any idea of what's the impact of taking off like proteins from meat or from fish and the learning capacities of the kids? And the other question is kind of the same thing with the exercise. You said you didn't have time to mention that, but there's a few studies talking about how exercise affects actually the learning. And there's some schools that actually go to the opposite side, that they put a lot of times for learning and not letting kids out to play out in the field. What is your thought on that also?
Okay, so the first one is on about the duration. So we have results showing that the naps should be long enough, say more than half an hour for sure. And I would say, based on not just our work, but other people's work, that the best nap would be the 90 minutes nap that has a full cycle of slow wave and REM sleep. If you go for the laboratory work, there are papers showing benefits with even like 6 minutes of a nap. But these benefits are usually just an offset of the fatigue. It's not really a plus for the learning. So probably we should stick to a full cycle, 90 minutes, so 2 hours are enough for you to fall in sleep and have a full cycle. Then the teachers usually say, oh, but then 2 hours, how can I take 2 hours from the schedule? Well, if we assume that most of the time the teacher is teaching, the children are not even paying attention, then this is where we should take the time from. The food, I don't know about the protein, I don't know anything about that. I know about fat. So there are studies, not in humans, but in rodents, showing that if you feed high fat or low fat chow to rodents, those that receive high fat basically don't learn even like half of what the other ones do. Okay, now this is we can still, there's a huge room for research there because we need to separate, it's completely different if you have omega-3, omega-6, or if you have, bad fatty acids. So this is a huge opportunity for us to really make it scientific, to make controlled trials in which we compare those things properly. For exercise, I think this is really a beautiful, renaissance. I think we are probably rediscovering stuff that the Soviet Union knew in the 50s, but it's published in Russian. But it's now very obvious that exercise is related to academic achievement, not just cardiovascular capacity, but also the ability to do coordinative exercises. There's transfer there, right? And if you think in terms of the circuits involved in speaking and in performing a variety of exercises and sports, collective sports, capoeira, there's certainly benefits there. There's a recent paper in Nature Medicine showing that exercise helps to prevent Alzheimer's and the whole molecular pathway involved in this. So I think that what we're doing is really wrong because exercise is usually relegated, can you say this? To the end of, I don't know how it is in France, but in Brazil, it comes at the end of classes. This teacher doesn't really talk to the other teachers. It's assumed that exercises are not related to declarative learning, right? So it's the first thing that people drop. If there's anything changing schedule, yeah, you killed that class. We probably should be doing exercise early in the morning to oxygenate the brain, to make the prefrontal happier, make the kids more able to learn, and integrate it with learning. Also to break the classes with exercise. So every half an hour, get people to move, get people to pay more attention. Where's Kathy? Where's Kathy? Okay, so this is Kathy's point. She always stresses this. And I think that those things which were once viewed as hippie or new age are now cutting edge science, and we need to pursue them.
Autre question? Wave your hands. Là.
It's okay? Yeah. Hello. You need about the need of sleeping in school, but until what age do you think that it's important?
90.
Temps pour une autre question, petite question.
Elena.
Here.
Hello, I'm a journalism student and we are doing a report for the Minister of Education. I just have a question. When you said that it helps someone to sleep more for his work, for him to work better, does it help him to be more focused because he's not asleep, or is it more scientific and help the brain to work better?
So let me see if I understood your question. There are benefits for pre-training sleep and post-training sleep, right? The kids come to school sleep deprived. So it's probably very wise to offer sleep early on, to say, do you need sleep? Get some sleep. Do you need to eat? Eat some. And then they learn, and then you have post-training sleep, which will specifically help the consolidation of those contents. Why am I separating the two? Because if you just give the post-training sleep, but the kid was too sleep deprived to learn in the first place, if there was no acquisition, there's going to be no consolidation. So we need to take care of the acquisition, and that's the pre-training sleep. And then we need to take care of the consolidation. That's the post-training sleep. Did I answer your question?
Yes, I think you did.
Yeah?
Yeah, thank you.
Merci beaucoup.
Merci à vous.
Thank you, Siddhartha.